Hi grade 11s and welcome to this video. In this video, we'll be working on the Mathematics Paper 1 for November 2024. And this is specifically from Eastern Cape. So the marks allocated as usual is 150 and the time is 3 hours. The instructions as usual, if necessary, round off to 2 decimal places unless stated otherwise, and the diagrams are not necessarily drawn to scale. Okay, with that being said, let's get into this video. Question 1.1.1 says we need to solve for x in this quadratic equation. Okay, so it's a quadratic equation. We can see the 2, the highest exponent of x. So we're going to open up 2 brackets and equate it to 0. And x times x is what gives us x squared. And now we need factors of -8 that can give us 2. So factors of -8, we can take 4 and 2, but one of them need to be negative so that we can get -8. So which should be negative so that you can ensure that you get a negative 2x in the middle. You need to make the 4 negative and the 2 positive because -4 plus 2 is -2. Okay, so our factors are -4 and +2. And so therefore, this means that x is equal to 4 or x is equal to -2. And those are our answers. Moving on to the next question. Question 1.1.2 says we have this equation and we need to solve for x correct to 2 decimal places, meaning our solutions are going to be irrational. Okay, so we're going to need the quadratic formula here. So it is a quadratic equation, but as you can see, it's not in standard form because one hand side is not equal to 0 in this case. So we're going to transpose that 7. So we have 2x squared minus 3x minus 7 is equal to 0. And there we go. Now it's in the form of ax squared plus bx plus c is equal to 0. And so because this is a quadratic equation, but we need to correct to 2 decimal places, so we have irrational solutions, we're going to use the quadratic formula, which looks like this. Okay, and so x is equal to, we'll say -b, and b is -3 as we can see, so -3 plus minus the square root of -3 all squared minus 4 multiplied by a, which is 2, and c, which is -7 all over 2a, which is 2. And let's get our solutions. Okay, so let's just check the mark allocation. Okay, so this is for 4 marks. So you're going to get a mark for your substitution. Of course, you also get a mark for putting it in its standard form. And then lastly, you'll get a mark each for your solution, which is really nice because in grade 12, they don't do that. This is only for 3 marks. Done. And of course, you also still get penalized if you don't actually substitute properly, okay, or round off properly. So that's good to know. Okay, so when we substitute, you see that x is equal to, and if we round off to 2 decimal places, this is 2 point, and that's going to round that 6 up to a 7, so 2.77, or x is equal to, and I will just change that plus to a minus, and this is -1.27, okay, and those are our answers. If this is for 5 marks and it's this kind of simple situation where you just have to put it in standard form, then it probably means they're going to give you a mark for the third form answer. So when you finally put that on the calculator, just try with a plus. Whatever third form answer it gives, like this, you're going to rewrite that. Of course, yours won't look like that. Yours will be negative, well, it's going to say 3 minus the square root of 65 over 4. That's what yours would say. Okay, so just keep that in mind. Moving on to the next question. Question 1.1.3 says we need to solve for x in this inequality where n is an element of natural numbers. Remember your natural numbers? These are natural numbers. Naturally, when you start counting, you start at 1 and then 2 and then 3 and so on. So those are natural numbers. So just keep that in mind. Okay, so now what can we do with this inequality? Well, they have already factorized it for you. You can choose to, do something with this. There are 2 ways that you can actually solve for this, and it will still give you the same answer. You can choose to actually take out this -1 as a common factor here because they put it in the order of 4 minus x. So the x is negative. So you could take out a negative 1 as a common factor, if you take it out from here, you're not just going to put it here because see how that changes what you're actually saying. You're going to put that common factor here. Okay, so the negative is outside. And now what you have left in this. In the first term over here, you will now have a negative 4 because you'll say this value divided by the common factor. So that's minus 4. And then here you just have negative x divided by negative 1 is x. And then this is what you would have is greater than 0. But then you're going to have to get rid of the negative. And to do that, you can either divide or multiply both hand sides by negative 1. And this is where the change happens. So here you have x plus 1 times x minus 4. But now the sign will change because you're multiplying by a negative value. Okay, multiplication or division by a negative number will cause the sign to change. So now this becomes less than 0. Okay, and then you have to solve for x in this. So we're going to deal with this using the graph method because you're in grade 11 now. In grade 12, you mostly use the graph method, not the number line method, okay? You'll see how that actually helps you with functions as well. Okay, so we're going to put down our number line, and what kind of parabola will this create? If you had to distribute, you would multiply the x and the x and you get x squared. And you will notice that this would be the highest exponent of x that you will have, meaning you're going to have a parabola that forms a smiley face, a concave parabola. And so our critical values, we're going to have to set those down. What are these x values over here? You simply find your critical values by equating these to 0. You're going to look at it as if this equation says, this inequality says, this, okay, is equal to 0. So you would say x plus 1 equals 0, therefore x is equal to negative 1, or x is equal to positive 4. So your critical values are negative 1 and 4. And now the question is, for which values of x, specifically where x is an element of natural numbers, we'll keep that in mind. For which values of x will this graph, okay, so will this be less than 0? Okay, when they're referring to that, for which values of x, you know that if you substitute x values in here, they produce outputs, which are y values. So they're referring to the y values of this graph. Y values of the graph that lie here, okay, in other words, these parts of the graph, they all map to positive y values. These are positive y values, meaning the values are greater than 0. That would be positive. And when they are less than 0, this means these are negative. So you're not looking for these values that are positive. The expression is specifically asking for which values of x are our y values negative, okay, less than 0. So we're going to look for y values that are all below here. These all map to negative y values. If you take a single point and you see what is the y value here, it's a negative number, okay? It's below the x-axis. So always just keep that in mind. If you're looking for positive y values, they will lie above the x-axis. And if you're looking for negative, they will lie below the x-axis. Okay, so let's understand where these values are. Where are these x values we're referring to? So when you highlight the parts of the graph that it refers to, if you line it up to the x-axis, let's see where these are. You can see that all of these values that we have mapped this to, okay, on the x-axis, these are all values that are greater than this number, negative 1. That's where negative 1 is here, right, on the x-axis. So greater than negative 1, but less than 4. Okay, so that would be our answer. We'll tell them this is simply where x is greater than negative 1, but less than 4. It's in between negative 1 and 4. But here's the thing. They specifically said where n is an element of natural numbers. So we can't just accept all of these. We have to specifically take natural numbers, meaning only the positive ones. If we were taking all the numbers that were greater than negative 1 but less than 4, look at these numbers. Greater than negative 1, meaning it's not including negative 1, okay? So it's after negative 1. We didn't say greater than or equal to negative 1. It's just greater than negative 1. So on a number line, these would be, we'll look at negative 1, and then 0, and then 1, 2, 3, 4. But we wouldn't include negative 1 and 4 because we're looking for values greater than negative 1 but less than 4. Okay, so we need to only include natural numbers. Which number here, or numbers, wouldn't be included if they're natural numbers? it would be 0. You can't include 0 because 0 is a whole number, not a natural number. Okay, it's an integer or whole number, not natural. So these would be our answers, 1, 2, and 3. So you can actually just tell them that x is simply equal to or is an element of, you can say x. Well, you can write it in two ways. X is equal to 1, or x is equal to 2, or x is equal to 3. And that will be your answer. Or you could just say x is an element of 1, okay, say 1, 2, and 3. So all of these numbers, and then that will be our answer. Okay, writing it like this or like this would be acceptable. Moving on to the next question. Question 1.2 says, given 14 over p is equal to p plus 5, solve for p. So let's rewrite our equation, and we need to solve for p. Okay, you see we have a fraction here, and then this is not a fraction. You can just make it a fraction by putting it over 1. And then to solve for p, we can just cross multiply. So p times p plus 5, so that's p times p plus 5. Since this is two terms, the p needs to get a chance to multiply into both terms. Is equal to 14 times 1 is 14. And now we just have to solve for p. Do not divide by p, okay? You don't know what p is. If p is equal to 0, your equation is undefined. We need to find the values of p, so don't cancel out that p. We're going to say p squared plus 5p when we distribute. And then we can transpose this 14. As we can see, it's becoming a trinomial. So minus 14 equals 0. And then factorize. So open up two brackets is equal to 0. P times p gives you p squared. But what times what gives you negative 14? That can give you a 5. Okay, 14 is an easy one because you know that 2 times what gives you 14? 2 times 7. So we can say 7 and 2. But then which should be negative, because this is clearly negative, which should be negative so that we have a 5p in the middle, positive 5p. You need to make the smaller factor negative. So if you say 7 minus 2, you get positive 5. Okay, so that is positive 7 and negative 2. So therefore, p is simply equal to negative 7, or p is equal to positive 2. And those are our answers. Moving on to the next question. Question 1.2.2 says, hence or otherwise solve for x if 14 over the square root of x plus 5 is equal to the square root of x plus 5 plus 5. Does that look familiar? Okay, yes, it looks exactly like the first one. You see how it's still saying 14 over a value, okay, that's the x plus 5, is equal to that same value plus 5. So it means that in this equation, we can see that we can just substitute in place of p, we can substitute this x plus 5. So since this simplified to p equals negative 7, we can simply say, okay, then that means let's just rewrite this. So we can simply say, okay, how about we let p equals the square root of x plus 5. And from the above equation, we were able to solve for this. So we can therefore say that we're going to, in place of p, substitute x plus 5. So you see how we knew that p was equal to negative 7 or p was equal to 2. We're just going to substitute. So in place of p, we'll say the square root of x plus 5 is equal to negative 7, or the square root of x plus 5 is equal to 2. Okay, but with this first one, just look at what we have here. We said the square root of x plus 5 is equal to negative 7. You're square rooting a value and you're saying it's equal to a negative number. That is impossible. Even if the number was negative, okay, it would not give you a negative value. It will simply just be a non-real number. So we can't really find this, or not really going to work with this, okay? So in this case, we can just say that there are no real solutions here for where this is equal. Okay, you can specify x has no real solutions. Okay, and now we can just work with this. So this is our equation. Yes, this is definitely possible. There is a value of x, which if we square root x plus 5, it can give us 2, okay, a positive value. So we're going to square both hand sides to get rid of that radical, okay, that's square root. So we have x plus 5 is equal to, and that gives us 4. And if you transpose 5, you get 4 minus 5, which is equal to negative 1. And that will be our answer, okay? if you substitute -1, you will get 2. Okay, and that is our answer for question 1.2.2. Moving on to the next question. Question 1.3 says, solve for x and y simultaneously, and we have two equations. You need to spot the linear, so you can work with the linear. Okay, so this is our linear equation. You can go ahead and just call this equation 1. Okay, grade 11 method. But really, you can just take this further if you like. But let's just deal with it like this in the simple way. We'll call that equation 1 and we'll call that equation 2. So from equation 1, do you see how x does not have a coefficient of like 3 or 4? It has a coefficient of -1. So we can clearly make that the subject. If you have -3y equals 1 minus x, if you transpose the x, it becomes positive, and you still have the 1 on the right-hand side, then just transpose this -3y. Okay, so it becomes positive 3y. So you really just have 3y plus 1 here, and we can call this equation 3. And then we're going to substitute equation 3 into the equation we didn't use, equation 2, and that will help us to solve for y. So wherever you see x, replace it with 3y plus 1. So you have x squared, meaning 3y plus 1 all squared, minus 2xy. So just rewrite the y first in front of the x, because there's an x there which you have to replace with 3y plus 1. And then minus, we have y squared minus 7 equals 0. And let's solve for y. So squaring a binomial, you can say 3y plus 1 times 3y plus 1. That takes long, and you're trying to solve for this. Just try to avoid mistakes, okay? So long methods can lead to mistakes here and there. So let's just deal with this, the short method. So we'll square the first term, which gives us 9y squared. Square the last term, which gives us positive 1. Then first term times second term is 3y. And then you just multiply it by 2, which is positive 6y. And that is what we have here. We don't really need brackets. Then moving on to the next term, we're going to distribute here. So this is negative 6y squared, and then negative 2y. Then minus y squared minus 7 equals 0. Okay, like terms together. So we've got 9y squared minus, and that's 3y squared, and the minus y squared is 2y squared. Okay, and then 6y minus 2y is positive 4y, and then this constant of 1 minus 7 is negative 6 is equal to 0. And now you see that there's a common factor of 2 all through. So we can divide both hand sides of this equation by 2. Therefore, y squared plus 2y minus 3 equals 0. And we have a quadratic equation. So open up two brackets, equate to 0. Y times y gives us y squared. And then this one is quite simple. It's just 3 and 1. But which should be negative since the 3 is negative, so that 2y stays positive. You should give the negative to the smaller factor. Okay, so positive 3 minus 1 is indeed 2. Therefore, y is equal to negative 3, or y is equal to 1. And so we've solved for y, and now we can use this to solve for x. So simply take an equation that includes x, or really the equation that had x as a subject, which is this, x equals 3y plus 1. Okay, so we'll say x is simply equal to 3y, and our y value here is negative 3 plus 1. And then that gives us negative 9 plus 1, which is negative 8. Or x is equal to, and this is 3, and then the y value here is 1 plus 1. So that gives us 4. Okay, so these are our answers. X is equal to negative 8, while y equals negative 3. Or x equals 4, while y equals 1. And that is our answer. Moving on to the next question. Question 1.4 says, if 2x to the power of negative 1 plus x to the power of negative 2 equals 3, okay, these exponents are just negative, and x is less than 0, determine without using a calculator the value of 2 times 6x minus 1 to the power of negative 1. Okay, let's just rewrite what they gave us first, and then we'll rewrite it as positive exponents. They have given us that 2x to the power of negative 1 plus x to the power of negative 2 equals 3. If you rewrite this so that the exponent is positive, remember that you only need to move whatever has a negative exponent. Now, when looking at this term, what needs to move they're currently in the numerator. Okay, they have a natural denominator of 1. So what needs to move? The x. Okay, this needs to move. The 2 doesn't have any problem. The 2's exponent is an invisible 1. It's fine, it has a positive exponent. So we can rewrite this as 2 over x. Likewise, with this one, you see that the x to the power of negative 2 needs to move to the denominator. So if it moves and becomes x squared, what's in the numerator? It's whatever was in front of this x, which is an invisible 1. Okay, so it's equal to 3. Okay, so now how can we simplify this? Well, there are 2 fractions and we need to add them. When you're adding fractions, you need to ensure that their denominators are the same. So you can do this by looking at the denominators and seeing that, oh, this can become x squared. And then you just multiply the numerator and denominator by x. Or you could say, okay, LCD method, which is the same thing at the end of the day. This is just a slower process. So our denominator, our common denominator, is going to be x squared. See, so this ends up being the exact LCD process. I just made sure to show this. Okay, so in the numerator, what do you have now? You have a 2x. And here, this denominator was already x squared. So there's the denominator of x squared, and the numerator was positive 1, is equal to 3. And now you have the situation of a fraction and a number. Just put the number, rewrite it as a fraction, okay, put it over 1, and then cross multiply. So we're saying x squared times 3, which gives us 3x squared, is equal to 2x plus 1 times 1. 1 times anything stays the same, so it's 2x plus 1. And now we can finally transpose. So you see how you have a quadratic equation, and they specifically said x is less than 0. So we'll keep that in mind. So we have 3x squared, and then this becomes minus 2x minus 1 is equal to 0, and we need to factorize. So we need to factorize, just think about factors of 3x squared. So 3x times x give you 3x squared. 1 is simple, just 1 and 1. But remember that this is negative. So 1 needs to be negative, 1 needs to be positive, but you need to ensure that you get a negative 2x in the middle. So here's how we can do this. I'm doing this using the cross method since we had a coefficient of x squared that was not a common factor. So we're going to cross multiply. That will give us 3x, and that will give us x. But we know that one of these should be negative, meaning one of these will be negative. So which should be negative so that you can ensure that you get a negative 2x in the middle, okay, or a negative 2x as your answer when you add them together. This means the 3x should be negative, okay, because if you say negative 3x plus x, you get negative 2x, and there we go, we got the middle term. And so now, because you know this should be negative, which number, okay, between 1 and 1, the top and bottom, which should take the negative? It would be the one that helped to create this 3x, which we know was 3x times 1. So this should get the negative, this should get the positive. So that when you say 3x times negative 1, you get negative 3x, and x times 1, you get x. Okay, so there we go. So our factors are simply 3x plus 1 and x minus 1 is equal to 0. And now we can finally solve for x. So here, 3x plus 1 equals 0, 3x equals negative 1, and then x is finally equal to negative 1 over 3. Okay, negative. Or x is equal to positive 1. So these are our 2 solutions. But remember that they said x is less than 0. So we'll tell them, but we know that x is less than 0. So we will not accept this because this is positive. We need to take the negative solution, meaning x is equal to negative 1 over 3. Okay, so we finally solved for x, and now we can find the value of what they were asking for, which is 2 times 6x minus 1 to the power of negative 1. So when we rewrite this, right, 6x minus 1 to the power of negative 1, do you see that this exponent is negative? And it's the exponent of 6x minus 1. So it means that the whole 6x minus 1 will move to the denominator. So this is equal to 2 over 6x minus 1. And now they have a positive exponent. 2 didn't move because it doesn't have a problem. The exponent is not negative. Okay, so it's equal to, we'll say 2 over, and in place of x, we'll substitute our x value of negative 1 over 3 and minus 1. Okay, so this is equal to Here we've got 1 over, okay, let me not do that. Let me say 2 over. This gives us negative 6 over 3, which is negative 2. So that's negative 2 minus 1, which gives us negative 3. And so, yeah, I'll just leave it like this. And then now say this is finally equal to negative 2 over 3. And that is our answer. Okay, and that is the value of this. And that is it for question 1. Question 2, 2.1 says, simplify fully without using a calculator. Okay, so they just mean don't take it and put it all into the calculator and give them a final answer. Okay, you need to show how it simplifies. So if you have the square root of 32, how do we simplify this? Well, it's a square root, so you need to look for a square number in 32. The best way to do this is to divide it by a prime number, its prime factor. So first prime factor of 32 is 2. 32 divided by 2, and that gives us 16. So that is 2 times 16. Okay, and then minus, we'll do the same thing with 18. So 18 can be divided by 2. 18 divided by 2 is 9. So that's 2 times 9. And you can see this is a square number. And then plus, we have 3 root 3. There's nothing we can do with that right now. So leave it like that. And then the square root of 108. Do we have a prime number in this? So divided by 2, that would be 54. But you can see 54 is not a prime number. So let's try dividing it by 3. If you say 108 divided by 3, we get 36. So this is the square root of, and then that is 3 times 36. That gives you 108. And then plus the square root of 8. So divided by 2 is 4. So this is 2 times 4. Okay, so let's simplify. Here, when we square root, you're going to square root the 2 and the 16. The square root of 16 is 4. So you have 4, but the square root of 2 still stays square root 2. So that stays square root 2. And then minus, and here we have the square root of 9 is 3. And the square root of 2 stays square root 2. And then that is 3 root 3 all over. The square root of 36 is 6. And we still have square root 3. And then the square root of 4 is 2. And we have square root 2. Okay, and now we're going to put our like surds together, okay? So if they have a square root 2 and a square root 2, they are like, and they can be added or subtracted. So 4 square root 2 minus 3 square root 2 is the same thing as saying 4x minus 3x, okay? So that gives you x, meaning square root 2. Then plus 3 square root 3. And here in the denominator, do you notice something similar that we have? Yes, they don't have square root 2's, like they're not like surds, but they do have the square root of 3 and the square root of 2. So this means that between these two, there's actually a common factor. 6 and 2 have a common factor of 2. So we can take 2 out as a common factor here. And then what are we left with in the first term? But I'm going to actually say what are we left with in this term here, because I can see that it's following this order, square root 2 and then square root 3. I'll let it follow the same order. So what are we left with in this term? You'll just be left with the square root of 2, okay? So if you said this, 2 root 2 divided by 2, you're just left with square root 2. And then here, what are we left with? Do the same thing. So that's just going to be 3 root 3, okay? And there we go. You see that the numerator and the denominator are exactly the same. They would cancel, and you're left with, in this numerator, you're left with a 1, and then the denominator, you're left with a 2, which is a half, and that is our answer. Okay, and that is question 2.1. Moving on to the next question. Question 2.2.1 says we need to solve x in this equation. Okay, so with this equation, do you see that we have a 2, we have a 64? Okay, the 2 is not raised to any exponent except for 1, of course. So we can just divide both hand sides of this equation by 2. And so now we have x to the power of negative 5 over 2 is equal to, and that is 32. Okay, so 32 can also be written as a base of a prime number. So we can do that. Just checking what this is, okay, quickly, just to see whether we will need to square root, because that is important to think about. If you put this back as a surd, okay, you have x, you have a radical, but this top is the inside exponent, so we can leave that as negative 5. And this is the outside exponent, so that's the 2. So it's a square root. You see that with this type of equation, you're never going to need to square root both hand sides. So you don't have to consider positive or negative solutions. Okay, so it's not one of those cases. So just keep that in mind. Okay, so let's rewrite this. And we're going to say x to the power of negative 5 over 2 is equal to, and this is 2 to the power of 5. And now what we can just do is multiply both exponents, or raise both exponents to the power of negative 2 over 5, the reciprocal of this exponent. Okay, so negative 2 over 5. So they would multiply, meaning now we have x. Okay, that cancels out completely. X is equal to, and here, because the denominator is a 5, it will cancel with that numerator of 5 in that exponent. So you have 2 to the power of negative 2. 2 to the power of negative 2, if you rewrite the exponent as a positive exponent, you're going to have 2 to the power of positive 2. And in the numerator, you have an invisible 1. Okay, that's in front of the 2. And then we have, you can see it as a placeholder. And so finally, x is equal to 2 squared is 4. So this is 1 over 4. And that is our answer. Moving on to the next question. Question 2.2.2, we have an exponential equation. So in this exponential equation, do you see that we have something repeating, or common factor? That's 5 to the power of x, okay, in both terms. So that's what we're going to do. We're going to take 5 to the power of x out as a common factor. Now, what we can do first is expand. So we'll rewrite this as 3 times 5 to the power of x. But this one will be written as 5 to the power of x multiplied by what gives you this negative 1 that we got there. Well, you must have said 5 to the power of negative 1, okay? Because if the bases are the same and you're multiplying, you would add the exponents, okay? So that minus is outside. And then this is equal to 14. And so this is equal to, we're going to take 5 to the power of x out as a common factor. And in the first term, you're left with the 3. In the second term, you're left with, don't forget the minus, you're left with 5 to the power of negative 1, which we can, of course, rewrite as a positive exponent, is equal to 14. And so 5 to the power of x, and then we have 3 minus, this is 1 over 5, and then is equal to 14. 3 minus 1 over 5, that is going to be, you can express this as 15 over 5. So that's going to be 14 over 5 that we have there is equal to 14. And then to get rid of this 14 over 5, you can choose to divide both hand sides by 14 over 5 or multiply both hand sides by 5 over 14. Okay, that's what will get rid of that. So if you say 5 over 14, you see that the 5 and the 5 in that denominator would cancel. 14 and 14 would cancel. Okay, so we're left with 5 to the power of x is equal to, and here the 14s cancel and you're just left with 5. So finally, we know that this has a natural exponent of 1. So the bases are the same, and therefore we can equate their exponents, meaning x is equal to 1. And that is our answer. Moving on to the next question. Question 2.3 says, calculate the possible value of a squared plus b squared if it is given that a and b are rational numbers, such that the square root of a plus the square root of b is equal to, okay, this. So a and b, the hint here is a and b are rational numbers. Okay, this is the equation that we get. Let's see what we can, do with this equation. So they have surds, and our goal is really just to try and find, a and b. So this is equal to the square root of 9 plus the square root of 56. Okay, so in order to get a and b, really, at the end of the day, we'll get a squared and b squared. So we clearly have to solve for a and b individually first, simultaneously, really. Okay, so we can square both hand sides of this equation first. So we can break that open to get closer to that a and b. We will definitely get an a plus b here. So when you square the first term, this is like saying x plus y all squared. Okay, the same order works for this because these surds are not like the square root of two different things. So we'd square the first term, and that gives us a, square the last term, and that gives us positive b, and then say first term times second term, to give us square root. Now, they're both square roots. So when you multiply things that have the same root, okay, if you're saying square root times a square root, not a square root times a cube root, then it's going to become the square root of that first value times the other value, okay? So that's going to be square root AB. And then you're going to multiply this by 2. It's the same thing as saying square root A plus square root B. And then you write it again, and then you FOIL out. You'll see that you'll get to the same conclusion, okay? So this is plus 2 square root AB, okay? So I suggest you pause the video and actually try that out on your own. And this is equal to, and so this will break open, and you have 9 plus the square root of 56. This one doesn't break open. It was protected. It was under this one. Okay, so only that broke open. Now with this, I can see something. You see how we have A plus B? Do you see that they initially said A and B are rational numbers? So if A and B are individually rational numbers, not irrational numbers, so they're not surds, okay? And we can see that A plus B plus 2 square root AB is equal to 9 plus square root 56. This is an irrational number. So that would mean that if these are rational numbers, even when you add them together, they would still give you a rational number. And so from this, I'm going to say A and B are rational numbers. Okay, mathematically, just writing it. But you could also just say it in words. A and B are rational numbers. So I'm saying, but I know that A and B are rational numbers. Okay, so that's the symbol for rational numbers. Irrational numbers look like that. Okay, so since they are rational numbers, that would mean that A plus B, okay, when you add them together, they would also give you a rational number, meaning they give you 9. And then that would mean that 2 square root AB is equal to the square root of 56. And so this is our simultaneous equation, and we need to solve for A and B. Okay, so in this equation, you can see how this is the linear. So we're just going to make A the subject. A is equal to, and we have 9 minus B, and I'll call that equation 1. I'm supposed to call that equation 1, but it's fine. Equation 1, and then this is equation 2. So we're going to substitute equation 1 into equation 2. And so this is 2 square root. We have A, now square root. A is 9 minus B, so I'll just write the B first. So that's B times 9 minus B. And then we have is equal to the square root of 56. Okay, so to get to this B, to solve for B, you see how this square root is the problem. So we need to get rid of it, and we can get rid of it by squaring both hand sides. So when you square, remember that this 2 and this root, they're just multiplying. That's why they're next to each other, okay? 2 times root 2 is 2 root 2. So this is going to square and become 4. And then that gets squared and the radical breaks open. And now you have times B times, okay, just use a big bracket. So times 9 minus B, okay, is equal to, and that breaks open to give you 56. And now we can start distributing. So this is 4 times, and that gives us 9B minus B squared is equal to 56. Okay, let's see if 56 is divisible by 4. So 56 divided by 4, yes, it is 14. Okay, so if you divide both hand sides by 4, then we're saying 9B minus B squared equals 14. And you can see this is already a quadratic. So this is, let's transpose everything to this side since the B squared is negative. So we have positive B squared minus 9B plus 14 is equal to 0. Okay, and now we can factorize. So open up 2 brackets, equate to 0. B times B gives us B squared. Factors of 14, they can give us 9. So 2 and 7, yeah, that works out. 7 and 2, and then just make them both negative because only the middle is negative, so both factors will be negative. Therefore, B equals 7 or B equals 2. So now to solve for A, because A was 9 minus B, let's just substitute. Since A was equal to 9 minus B, we're simply saying A here, if B is equal to 7, it is 9 minus 7, which is 2, or A is equal to 9 minus 2, which is 7. Okay, so you see that ultimately A is equals 7 and B equals 2, or A equals 2 and B equals 7, right? And all we're trying to find out is the value of A squared plus B squared. So regardless whether A is equal to 2 or B is equal to 7, you know that you're going to square both of them. Okay, so you're going to say A squared plus B squared. So even if we said 2 squared plus 7 squared or 7 squared plus 2 squared, they'll still give you the same answer. So let's just pick one. It's still going to be exactly the same. Therefore, we have 2 squared plus 7 squared, and then this is equal to 49 plus 4, which is 53. And so A squared plus B squared, that gives us 53. And that is our answer. Okay, that was the final answer. You can also try it as 7 squared plus, you see how it's just going to be exactly the same thing. So that is our answer. And that is it for question 2. Question 3.1 says, consider the linear number pattern, -5, -9, -13. So write down the next two terms of the pattern. They already tell you it's a linear, so you know there needs to be a constant difference. Okay, so you can see that from, if you say -9 minus -5, okay, you get -4. And really, it's just because -5, from -5 to -9, you must have said -4. And from -9 to -13, -4. So to get the next term, -13 minus 4 is -17. And then -17 minus 4 is -21. And that is our answer. Moving on to the next question. Question 3.1.2 says, determine an expression for the nth term of the number pattern. So we need a general term. Okay, so it is linear, so you can use the formula Tn equals A plus n minus 1 multiplied by D. Okay, and so A is the first term and D is your constant difference. So Tn equals, and our first term is -5 plus n minus 1, and our difference is -4. So if we distribute here, we have Tn equals -5, and then we're distributing. So that's -4n, and that is +4. So Tn is finally equal to, we have -4n, -1, and that is our answer. Moving on to the next question. Question 3.1.3 says, calculate the value of n for which Tn equals -141. We already know that Tn is equal to this, so in place of Tn, substitute -141, and this is -4n minus 1, and we're just going to solve for n. Okay, so transpose this -4, I'm just going to make it +4n is equal to, and that becomes +141 minus 1, which is +140. And now we have divide both hand sides by 4. Therefore, n is simply equal to -140 divided by 4 is 35. Okay, because 35 plus 35 is 70. So that's double of that. Okay, so that is our answer. And moving on to the next question. Question 3.2 says, in a linear number pattern, the first term is x. Okay, it's a linear pattern, and the first term is x. And a common difference is I think they meant the common difference is 5 less than the first term. Okay, so let's put that down. The first term, okay, T1, that is x. And the common difference, that D value, is 5 less than the first term. So if this is the first term, we're saying 5 less than this, so -5. Okay, and they want us to calculate the value of the first term, so ultimately find x, if it is given that the sum of the first 3 terms of the linear number pattern is 63. Okay, sum of the first 3 terms, meaning term 1 plus term 2 plus term 3 is equal to 63. So straight away you see that we need to find term 2 and term 3. We know term 1 is x. So how do we find term 2 and term 3? Well, remember how terms go, and this is a linear pattern. So if the first term is x, how do you get the next term? You say first term plus that difference, which we know is x minus 5. So x plus x minus 5 will give us the second term. Okay, so the second term is 2x minus 5. And then the third term would be this plus x minus 5, which would be 3x minus 10. Okay, because negative 5 minus 5, we're just adding. So in 3, we're saying 2x minus 5 plus x minus 5. Okay, so you see how that just gives us that. So we know the first three terms, and we just need to add them up, and they give us 63. So we're saying term 1 is x plus term 2 is 2x minus 5 plus term 3, which is 3x minus 10, and then that gives us 63. So let's add. These will give us 3x plus 3x is 6x. And then negative 5 minus 10 is negative 15 is equal to 63. Then 6x is equal to 63 minus or plus 15 really. So 63 plus 15 is 78. And if we divide both hand sides by 6, x is finally equal to what is 78 divided by 6. It's 13. And that is our answer. The first term is 13. Okay, and that is it for question 3. Question 4 says, given the number pattern 4, 10, 0, and negative 6, show that the above number pattern is quadratic. Okay, how do we differentiate between a quadratic pattern and, other patterns or a linear pattern? Well, if we have a quadratic number pattern, you will notice that that pattern will have a first difference, okay? And that's going to be a linear pattern. And then you can find a second constant difference. So if we can show them this, then we will know that it is quadratic. So let's write down our pattern first. And so negative 6 minus 0, that just stays negative 6. And let me just put it on the next line, negative 6. Then 0 minus 10 is negative 10. And then 10 minus 24, that is negative 14. And then that is our first difference. So now we need to find the second constant difference. If it's constant, then you know this is a quadratic pattern. So you can see that you could just say negative 6 minus negative 10. And so that becomes negative 6 plus 10, which is indeed positive 4. Okay, so we're just adding by 4, really. Okay, and then negative 10 minus negative 14 is also positive 4. Okay, and there we go. Because we have a second constant difference, emphasis on constant. Because it is constant, then we know, yes, this is indeed a quadratic pattern. And that is our answer. Moving on to the next question. Question 4.2 says, determine the nth term of the quadratic pattern in the form of Tn equals an squared plus bn plus c. Okay, we already have everything we need now. You can take the first three terms of the quadratic, the first difference and the second constant difference, and equate them to the following. So we'll equate the second constant difference to 2a, and then this will be equated to 3a plus b, and then this is a plus b plus c. Okay, and it's always equal to the first term in each. So 2a equals 4, and therefore if you divide both hand sides by 2, a is equal to 2. And 3a plus b equals negative 14, but we know a is 2, so 3 times 2 plus b equals negative 14. And let's say b equals negative 14, and this gives us 6, but when you transpose it, it's negative. Therefore, b equals negative 20. And then a plus b plus c, but we know a is 2, b is negative 20, plus c equals 24. And then we can just say c is equal to 24. And here 2 minus 20 is negative 18. If you transpose, it becomes positive 18. And so therefore, c is equal to, that gives us 12, and that's 30, so 42. And there we go. So it means that Tn is equal to, our a value is 2, so that's 2n squared. Our b value is negative 20n, and our c value is positive 42. And that is our answer. Moving on to the next question. The next question says, calculate the value of term 52. You see, in place of Tn, we've substituted in place of n 52. So that's exactly what we're going to do. Term 52 is equal to 2 times 52 all squared minus 20 times 52 and then plus 42. And let us see what we get. I'm just going to put this on the calculator. And that gives us 4,410. And that is our answer. Moving on to the next question. The next question, 4.4, says, determine the smallest value of the quadratic number pattern. The smallest value. Now, think about what your quadratic number pattern would look like if you drew the graph out. Do you see that if you had to ignore this part, okay, and in place of n, substitute x. Okay, so if we did that, put x here and x, do you see that this is a quadratic expression that we have? Okay, y equals this. So this will create a graph, a parabola specifically. And it's going to be a parabola with a what type of face? Happy face or sad face? It's going to be a happy face. So it's concave up. And do you see that this parabola, if we had to put this on a Cartesian plane, this is going to have a minimum value. So here's what I mean by this. You see, if you look all through this parabola, okay, that's a y value that it has over here. Remember, we're always concentrated on the y values, the results that this parabola has. Okay, so here's another y value. Here's another y value here. But all through, looking at all these y values, the lowest y value you will have would be over here. That is the lowest that this graph reaches. After this number, okay, it doesn't go anything below this. You see, there's no graph down here. This is the smallest value or the lowest value that this parabola will ever have, that this quadratic number pattern will ever have. Okay, of course, given that n is a natural number, that is also important, because the thing about a parabola is the reason why it's not going to look exactly the same, the results won't look exactly the same as the number pattern, is because with number patterns, you can't have term values like -1, okay? But on the parabola, you can have an x value of -1, that's fine. But with a pattern, it's not possible because you cannot say the negative first position. There's no such thing. Or the -1/2 position. No such thing, okay? So a quadratic pattern will always have term numbers that are natural numbers specifically, okay? But here's the thing about it. We can find the lowest one. The lowest one happens here at this special point called the what? It's called the turning point. So that's what we're going to do. We're going to find the y value of the turning point of this parabola, of this quadratic number pattern. Okay, so in place of n or x, I'm just going to put back n. So this is Tn. And so to find that lowest value, we're going to find that y value of the turning point. We find the y value of the turning point by finding the x value first. To find the x value, you simply say x is equal to -b/2a. That is the formula to find it. But I'm just saying n is equal to in this case because I'm trying to find an n value. So n equals negative, and our b value is -20/2 times 2. Okay, so n is equal to, that's going to give you +20/4, which is equal to 5. Okay, so we know n equals 5, okay? That is just the term number that it belongs to. They want the smallest value, okay? The value. So we're going to say, what is the fifth term? And that will give us the value of the fifth term. That's the smallest value, okay? So 2 times 5 all squared minus 20 times 5 plus 42. Okay, so in a nutshell, what we're doing is we have our parabola, wherever it is, it has to be negative and a positive root because only the middle is negative. So with this, we know that it happens where n is equal to 5. Okay, that's the x value, but we want the y value, and that's all we're doing. We're substituting x equals 5 so that we can find the y value that corresponds with this. Okay, so let's go ahead and substitute and find this. And we can see that the smallest value that this parabola will ever have, or this quadratic pattern will ever have, is -8. Okay, and the reason we were able to accept this is because you see that n is equal to +5. It's not a negative number. So it's part of our term numbers. So we were able to accept that. And that is our answer. Moving on to the next question. The next question says, determine the value or values of n for which the terms of the quadratic pattern will be positive. Okay, the terms, so really the term values. Okay, Think about it. They're just term values. And when we were trying to find, for example, the smallest term value, we simply took this and then we were able to find that. So you see that whenever you're referring to the term values, we're going to use the TN formula because this will always produce term values. So we're trying to find out where our term values will be positive. Positive numbers are numbers that are greater than 0. And this is what we're trying to solve for. So we'll rewrite our pattern. It is 2n squared minus 20n plus 42. And we need to ensure that this is greater than 0. And so we just need to solve for this inequality. Okay, so there's a 2 all through. We can divide both hand sides of this equation, this inequality, by 2. Therefore, we have n squared minus 10n and then plus, that's going to give us 21 is greater than 0. Okay, factorize. Open up 2 brackets, it's greater than 0. N times n gives us n squared. And then factors of 21, that can give us 10. 7 and 3. 7 and 3, and we can just make them both negative since only the middle is negative, meaning negative 7 times negative 3 gives you positive 21, but negative 7 minus 3 gives you negative 10. Okay, so this is what we have, but this is quadratic. You can't just start saying n is greater than 7 and stuff like that. So our critical values, that's what we need to look at. That is n equals 7 and n equals 3. Remember, it's just the same as equating it to 0. And now, if this is your graph, okay, n squared minus 10n plus 21, you don't have to look at it from this point. You can just look at it from the point where, you factorize and you have one hand side equal to 0. If this is our graph, what kind of parabola does it form? It forms a concave arc parabola, okay, a smiley face parabola. But remember, you're going to use that word concave in grade 12 most of the time. Okay, so you can just try to get used to it. So we have our lower critical value is 3 and the higher one is 7. And this inequality is asking us to solve for n for where this expression will be greater than 0. Remember, if the values, they're referring to the y values, the results, okay, the values of Tn. If the values are greater than 0, they lie above the x-axis, because if you map them to the y-axis, if you map them to find out the y values they produce, these are positive y values. Okay, so when they are greater than 0, they map to positive y values. When they are less than 0, they'll map to negative y values. Okay, and so we're looking at these y values because these are the ones that will be positive. If you line them down to the x-axis, then you can see that these values we're solving for n in this case. Here, the first solution is where n is, look at where these values are, the direction they're going in. All the solutions we have compared to 3, they're moving to the left-hand side of 3. So these are values that are less than 3. Or n is, and these are values that are greater than 7. Okay, so those are our answers. N is less than 3, but greater than 7. But now let's just think about this logically. Because they said, determine the values of n for which this is a pattern. Okay, it's not a parabola. It's not just like we're solving for x in a parabola where we can accept all real solutions of x. Okay, this is a pattern. You can't have negative term values. So let's think about the values we'll get. When we say in 3 and we have 7 and we're looking at values that are less than 3, this is like values like 2 and 1 and 0 and negative 1. You can't take values like that. You can't take negative 1. You can't take 0 because these will not be term values. We don't have the term number 0, okay? The 0th term or the negative first term. You only have term values like term 1, term 2, term 3. So basically, we need to remember that n is an element of natural numbers. So keep that in mind. If these are only going to be natural numbers, we need to only accept specific values. Now with the 7, it's not really a problem because you see that you can accept all the values here where n is greater than 7, okay? As long as it's not a fraction. So I'm going to point out that n is an element of natural numbers, so we can accept numbers like 8, 9, and 10, not 7, of course, because it's greater than 7, not equal to 7, okay? So here are our answers. We can accept 1 and 2. 3 is not included because they say less than 3, not equal to 3. And then values greater than 7, we can accept 8, 9, 10, and everything else. Okay, so clearly you can take numbers like 1, 2, 8, 9, 10, everything greater, every natural number greater than this. So we can just say n is greater than or equal to 1, but less than 3, okay, not equal to 3. And now we can accept all of these numbers greater than 7. Okay, so we can say n is greater than 7, but you need to remember that n is an element of natural numbers, and then that would be our answer. Okay, so remember, you can't really say equal to 3, because if you're saying equal to 3 or equal to 7, if you substitute 3 into this equation, you get 3 minus 3 and then 3 minus 7. But 3 minus 3 is 0. 0 times anything stays 0. They want the numbers to be positive, not equal to 0. 0 is not a positive number. It's neither positive nor negative. Okay, so these will be our answers. N is greater than or equal to 1, but less than 3. Or n is greater than 7, where n is an element of all natural numbers. And that is our answer. And that is it for question 4. Question 5 says, the lines y equals negative x plus 4 and y equals x minus 2 are the axes of symmetry of the function. Okay, so they're the axis of symmetry. Okay, so that's the positive axis of symmetry, the axis of symmetry with a positive gradient and the one with a negative. So if those are the axes of symmetry of whatever our hyperbola looks like, right? And this is the way they look. I'm just moving this one to this side. Okay, what is going on here is they will intersect at some point. And the point that they intersect at, that would be the same place that the vertical asymptote and the horizontal asymptote would also intersect. Okay, so when you have a hyperbola in the form of y equals a over x minus p plus q, that's going to be the value of p and q. Also, just notice how they've made that p positive. Okay, so if these are the equations of your axis of symmetry, and this is the equation of your function, you need to show that p equals negative 3 and q equals 1. So what is the one thing that happens with the axis of symmetry? They would intersect. And so because they intersect, you know that to find the point of intersection, you just equate these equations. Okay, so we're simply going to say y equals y, and I'm going to start with this one because I want to leave the negative on the right. So this is x minus 2 is equal to negative x plus 4. And now if we transpose, we have 2x is equal to, and that becomes a positive 2, which is a 6. So divide both sides by 2. X is equal to 3. Remember, that's not p yet, okay? They've just made a little change there. And so to find the y value of the point of intersection, we'll just substitute this 3 into either one of the equations. So you can substitute it into x minus 2, which is 3 minus 2, and that is 1. So from this, we can see that p would be equal to negative 3, and the reason why is because we can see that x is equal to 3, meaning in our original equation, a over x minus p plus q. When you substitute that here, it's going to say x minus 3. And so you're finding the value of p, the p that they are referring to. For you to get x minus 3, you must have said x plus negative 3. And that's why p is equal to negative 3. So we'll tell them p equals negative 3. And you see with q, that doesn't change. It's still plus q and it's still plus q here. So q is simply equal to 1. Okay, that's the x and the y value of the point of intersection of your axes of symmetry. So that is our answer. Moving on to the next question. Question 5.2, calculate the x-intercept. Yeah, they probably want you to draw the graph eventually. So let's just complete our equation. F of x is equal to negative 3 over, and we have x minus 3 and then plus 1. So to find the x-intercept, this is specifically where y is equal to 0. So we're going to make y equal to 0. So f of x is 0. 0 equals negative 3 over x minus 3 plus 1. If you transpose this to make it positive, it's now 3 over x minus 3 equals 1. And then you can cross multiply. So x minus 3 times 1 stays x minus 3. And then 3 times this invisible denominator of 1 stays 3. If you transpose, that becomes plus 3. And so x is equal to 6. And so there we go. They just want the x-intercept. They didn't say the coordinates, so we can just say x equals 6 is our answer. Moving on to the next question. Question 5.3, they want the y-intercept. So yeah, they want us to clearly draw this graph eventually. So to find the y-intercept, this is where x is equal to 0. So in place of x, we will substitute 0. So this is our equation, and we'll say in f of 0, okay? So 0. And let's see what f of 0 gives us. So this is going to be negative 3 over negative 3, which is 1. 1 plus 1 is 2. So there we go. F of 0 is equal to 2. And that is our y-intercept. Okay, so y equals 2 is the y-intercept. Moving on to the next question. Question 5.4 says, sketch the graph of f. Clearly label all intercepts with the axes and the asymptotes. Okay, so let's just draw our Cartesian plane down first. Okay, so because we already had the equation of the graph, you can see here that the vertical asymptote, okay, x minus p, x is equal to 3. Okay, so that is the value. We said x minus p, so the p value is what we have there. Okay, so, and y is equal to 1. That's the horizontal asymptote. So we'll just keep that in mind. X equals 3, y equals 1, and we need to put that down first. So x equals 3, it's a vertical line, so it's standing. So we'll just go maybe somewhere here, and we'll say this is our x equals 3, and it should be a dotted line. Okay, and then y equals 1, and I'll just put that over here. So y equals 1, and then make sure you write the equation as well. And now we can put down our intercepts. Okay, the x-intercept and the y-intercept. The x-intercept was x equals 6. So on the x-axis, we have this intersecting at 6. So that would be here, okay, 6, and that's 6 and 0. And then the y-intercept was 2. So on the y-axis, it intersects at 2. This is 1, let's just say that is 2. So 0 and 2. Okay, and now we can draw our graphs. So our graphs, looking at this, the a value, okay, a over x minus p, it's negative. If a is negative, your graphs lie in the second and the fourth quadrant. Okay, if it's positive, it's in the first and third. So that's where it's going to lie. And so you can just draw your graphs. So one will go like that, and then there you go. That's one wing, okay, from the same graph. And then the other will go like this. So coming from being really close to the asymptote and heading closer and closer, but never touching it. And those are the wings, and that is the graph of f. Okay, and that is it for that question. Moving on to the next question. Question 5.5 says, write down the domain of G if G is the reflection of f along the line x equals 0. Okay, let's understand where that line is and what it looks like. X equals 0. Notice if a line, the equation of a line starts with x equals, it means that it is a vertical line. So this is x equals 3, x equals 0 is here. So this graph G has been reflected across the y-axis. Okay, so if it's reflected across the y-axis, then it means that the graph of f, all its x values will change. And you can just look at it like this. If this is your y-axis and it's going to be reflected across this, let's just focus on the main thing. They want us to tell them the domain of G. The only thing that will affect the domain, okay, all the x values, okay, of a hyperbola would be this. Because you see, with the hyperbola, it has basically every other x value on this number line. Okay, look at the number line. See, it has an x value all through. So it has an x value here, has another x value here, and here, and here, and here, everywhere except for x equals 3. So we just need to find out that exception, the one place it's not going to have an x value. So what would this asymptote look like on the reflection? If this graph was reflected in the y-axis, it's going to reflect it through this y-axis. Therefore, it's not going to be x equals 3 anymore. It's going to be what? Remember, it's a reflection. So from the y-axis to this point, we went exactly 3 units to the right. The reflection would now appear from the y-axis exactly the same amount of units to the left. So you'd go 3 units to the left, and now you are at this point where you have this vertical asymptote being equal to x equals negative 3. So that's exactly what happens. It gets reflected across the y-axis. The graph of G now has a vertical asymptote of x equals negative 3, okay? But now we need to answer their question. So we're just saying that this is the vertical asymptote of G. Okay, so what is the domain of G? You see how the domain here, okay, we could see that it has almost every single x value. Same thing. It will have every other x value except for x equals 3. So it means that the graph of G will have every other x value except for x equals negative 3. So we can say that the domain is x is an element of all real numbers, but x is just not equal to negative 3. And that is our answer. Moving on to the next question. The next question, 5.3, says, for which values of x will x multiplied by f of x be less than or equal to 0? Okay, so x will be all the x values and then f of x is the y values. So you're looking for this combination. When you multiply them, they give you a value less than or equal to 0. For them to give you a value equal to 0, either one of them can be equal to 0 and then it would work out. So keep that in mind. If you ever see x is equal to 0 or y is equal to 0, we will consider those ones as well. So we have x multiplied by f of x. So if x was positive, we'll look for where x is positive, and that will be the positive part of the x-axis, okay? Multiplied by when y is negative, then they would give you a negative value, a value less than 0. And then we would also look for any place where we can see on the graph that x is negative and then the y values are positive, and then they will give us a negative result. Okay, so this is what we're looking for. Where is x positive? Okay, when you're saying x is positive, you're just looking at the x-axis and the values on the x-axis. Positive x values or positive or equal to 0 x values lie here, right? Now for these same x values, you need to ensure that the graph of f has y values that are negative, okay? We need to have positive x values, negative y values. So let's see. Where does the graph of f have negative y values for these same x values? We can see that there's a part of the graph up here for these same x values, but here, this part of the graph is above the x-axis. It has positive y values. If you map it to the y-axis, those are positive y values, so we can't take that. Now, if we look over here and see what's going on here, all through here, this still has positive y values. So we can't take that part. But when we now look at this part, okay, do you see that this part has negative y values? So this is where the x values are positive, but at the same time, the y values are negative. Okay, so we wouldn't take, this part. It's just here within this region. So this part. So if you line this up to the x-axis to understand where these x values are, you see that these are values that are, if this is 3, these are values that are greater than 3, and then they stop here, okay? So at 6 has an actual y value of 0. So we can see that this happens where x is greater than, okay, I need to put that 3 here, greater than 3, but less than or equal to 6, because it works for 6 since this has an actual y value of 0. 0 multiplied by this positive x value of 6 is still 0. So it meets this criteria. Okay, so here we can see that this works for x is greater than 3, but less than or equal to 6. I can't say equal to 3 because at 3 we have an asymptote. The graph will never have an x value of 3. Okay, do we have this scenario happening? We see that this one worked. We could find something like that. Now, can we find this case where the x values are negative and at the same time the y values of the graph are positive? Okay, let's see. Where the x values are negative, that will be all through here. But for these same x values, the y values of your graph must be positive. You see the graph? It's above the x-axis. It will have only positive y values here. Okay, if you map it to the y-axis, you see that these are positive y values. So this is, let's just find out the values of x for which this works. If you line this down to the x-axis, you can see that this starts at 0, and we're going to include 0 in this case because at 0, the x value is 0. If you take that x value of 0, multiply by the y value that goes with that, okay, of 2, the y value of that graph is 2, then you see that they do give you 0, which is one of the requirements we're looking for. So that is starting at 0, and then it's all values less than 0. So we can simply tell them here, or x is less than or equal to 0. And that is our answer. Okay, you can write it the other way around since 0, comes before 3 and 6. So like that, and we can say x is less than or equal to 0, or x is greater than 3 but less than or equal to 6. And that is our answer, and that is it for question 5. Question 6 says, sketch below is the graph of f of x, which is equal to, and we can see this is a parabola, specifically a concave parabola, smiley face parabola, okay? And they say for where x is an element of negative infinity to 6. Okay, so this graph only exists, they're cutting it off. It only exists from negative infinity all the way to 6, and this is the cutoff point. So we won't look at anything beyond this. Okay, a and b are the x-intercepts, and c is the y-intercept of f. Okay, and the first question is to determine the value of f of 6. Okay, self-explanatory. F of 6, in place of x, substitute 6. So that's what we're going to do. Take the equation of f and substitute 6. Okay, and so f of 6 is equal to, that's 36 minus 24. 36 minus 24 is 12, minus 5 is 7. And that is our answer. Moving on to the next question. The next question, 6.2, says, determine the coordinates of A and B. Okay, so A and B, we know these are x-intercepts. And at the x-intercepts, y is equal to 0. So we're just going to make y equal to 0. So here's our equation. And in place of y, we'll just say 0 is equal to, okay, so factorize, and we have x multiplied by x and 5 factors of 5 that can give us -4, -5, and +1. Okay, so x is equal to 5 or x is equal to -1. And then you just have to choose which is A and B. So -1 and 5, this is -1, that is 5, and just putting them down because we'll probably need them. So we can finally conclude A is -1 and 0, and B is simply 5 and 0. Moving on to the next question. Then question 6.3 says, hence calculate the length of AB. Okay, AB, since A and B are x-intercepts, to find the length of AB, you can simply just say, okay, I went 5 units to the right to get to B, 1 unit to the left to get to A, and then 1 plus 5 is 6. Or you could say the higher x value minus the lower x value, which is 5 minus -1. And then you can see that that gives us exactly 6 units. And that is our answer. Moving on to the next question. Question 6.3 says, write down the equation of g in the form of g of x equals ax squared plus bx plus c if it is given that g of x is obtained by shifting f 2 units to the right and 5 units up. Okay, so just think about the translation. 2 units to the right. If a point is shifted to the left or the right, it's only going to affect which coordinate, x or y. If I say shift this point 2 units to the right, you shift it to the right from this point and it becomes 2, 3, 4. Okay, so it becomes 4 and 1. Only the x value will change. So left or right movements affect the x, and up or down movements affect the y. So we are shifting the graph of f 2 units to the right and 5 units up. So here is how we can just write this down. Okay, so g of x, the new graph, is equal to, we take the graph of f, and in place of x, because we are shifting, okay, to the right, so it's going to affect the x. If the graph shifts to the right, when you apply it into your equation, you're going to use minus, okay? Right movement, you're going to say minus. And if it's moving to the left, then you say plus. So this is going to be f of x, and then we're going to say minus 2, because 2 units to the right. And then if it's moving up, it's really simple. Up, you add. Down, you subtract. So once we shift it to the right, this now becomes the result of shifting it to the right. It'll give us all the y values. Okay, so what we're going to do is we're trying to shift it 5 units up. So this becomes our new y, okay? And you're going to shift it 5 units up by adding a 5 to it. Okay, so this is a mathematical explanation for what we're doing, and now we're just going to apply it. So g of x is equal to, and we're looking at the graph of f of x, which looks like this. So let's just rewrite that down somewhere. Okay, and in place of x, what this is saying is whenever you see x, replace it with x minus 2. So here is our equation. We're going to say that's x squared, so that's x minus 2 all squared. And then minus 4x, and then that's x minus 2. And then minus 5, but then here we have plus 5. So you're going to add 5 to everything else. So plus 5. And now we're just going to find the equation of g. So simplify it now. Okay, so first term squared is x squared. Last term squared is positive 4. Multiply them both, and then times 2 is negative 4x. And then distribute. So negative 4x, positive 8, and negative 5 plus 5 is 0. Okay, so finally g of x is simply equal to x squared. That becomes negative 8x, and then positive 12. And that is our answer. Okay, moving on to the next question. Question 6.5 says, suppose h is a tangent to the curve f at a certain point with a gradient of negative 2. Calculate the y-intercept of h. Okay, so it has a gradient of negative 2. H is a tangent at the end of the day, right? And a tangent is a straight line. So it's in the form of y equals mx plus c. And so we only know the gradient, meaning it's currently negative 2x plus c. And we need to find out the value of c, really, the y-intercept that will ensure that this is a tangent to f. So looking at the graph of f, if this is the graph of f, and we have that graph of h with a negative gradient, so it's a decreasing function. So it could look something like this, and it's just going to touch it. A tangent touches a curve once, okay? Not like this. This would intersect, and so it cuts it at 2 places. It only touches the curve once. So this is basically what we're trying to ensure. Okay, we're trying to ensure that this is what we have, and then we need to find out the y-intercept for which this is possible. Okay, so what is the y-intercept of h? Okay, so if you're in grade 12, you would probably deal with this in a different way, but it's not impossible to work with in grade 11 still. You still have enough info to deal with this question. So here's what we can do. It's still a tangent. So at some point, the graph of f and the graph of h are equal. And we're going to use that. So we're going to equate the graphs. So we are saying that they're equal at some point. And it's still going to be in terms of c because we don't know what c is. We didn't find it yet. Okay, so it's still missing. And we will use the discriminant to find out the values of c for which this will be a tangent. Meaning, if it's a tangent, it only intersects with this graph once. And so it's only going to have one solution, one point of intersection. So we'll find out the values of c for which this graph of h, which is equal to negative 2x plus c, will have one root, okay? Or really the same root. Here's what I mean by this. So we'll take the graph of f of x, right? And we already have the equation of f. And we're going to equate it with h of x because it's a tangent, yes, but they do meet at this point. So we're equating them. And so f of x is x squared minus 4x. So this is x squared minus 4x and then minus 5. And we're going to just say is equal to h of x, which is currently negative 2x plus c. Okay, so this is our equation. And you see that c is still missing, and that's great. And so we're going to transpose this so that we can find the roots. So x squared minus 4x. And then this is positive 2x when it comes over. So it becomes negative 2x. And we have minus 5 and c comes over and becomes negative c is equal to 0. And this is the equation we have now. Now, you see how we equated those equations, right? So when you solve for x, you're trying to find out the points of intersection between this graph of h and this parabola. But you specifically want there to be one solution, okay? We want to ensure that h only intersects with the graph of f once, okay? That is a tangent to the graph of f, really. And so in order to make sure that that happens, this is our equation now. We're going to control this using the discriminant. So the discriminant delta equals b squared minus 4ac, right? This is the part of the quadratic formula that tells you the nature of your roots. So we're going to simply say, make delta, ensure that delta is equal to 0. Here's the thing. If delta is greater than 0, we're going to get roots that are unequal. So this could be something like x minus 2 times x minus 3, okay, is equal to 0. And so your solutions here will be x equals 2 or x equals 3. We don't want that. What that would look like on our graph means that this was maybe shifted a little higher, and so it's intersecting with this graph twice, okay, at 2 points. We don't want that. We want there to only be 1 point of intersection, okay, to ensure that it's a tangent. So we're not going with delta being greater than 0. We're going with delta being equal to 0, because if delta is equal to 0, you're going to get the same root. And what they mean by the same root, or equal roots, really, that's what it's called, equal roots. So what this means is you're going to have something like x plus 2 and x plus 2. See how those are the exact same thing? So if you solve for x here, x is simply equal to negative 2. That's what we want, okay? We want there to be one solution. And so that's going to ensure that it intersects with the graph only once. And it will have one specific x value for which it intersects with the graph, and one specific y value, of course. Okay, so let's go ahead and find this. Okay, so we're saying the discriminant is equal to 0. And so that is b squared minus 4ac. B is negative 2 all squared minus 4 multiplied by a. And we can see the coefficient of x squared is 1. And then c, I feel like I should have called that something else instead of c, but it's fine. Okay, so c is whatever the constant is. The constant is whatever does not have x. Okay, despite the fact that this is a letter, it's still part of c. Okay, so negative 5 minus c, that is c. So negative 5 minus c, and we're going to say it is equal to 0, not greater than 0. So negative 2 all squared is 4, and then this just becomes negative 4. If you distribute that in, you say negative 4 times negative 5, which gives you positive 20, and then times negative c, which gives you positive 4c is equal to 0. And then 4c equals, and we have 24 here. If you transpose it, it becomes negative. Divide both hand sides by 4. Therefore, c is simply equal to negative 6. That is what the y-intercept must be. Okay, c was our y-intercept of the graph of h. C must simply be equal to negative 6. So we can just conclude the y-intercept should be equal to negative 6 for that to be a tangent to the graph of f. Okay, so that is our answer. Moving on to the next question. Question 6.6 says, for which values of k will f of x minus k equals 0 have just one real root? F of x minus k equals 0. Okay, we can look at the graph really for this, because if we're saying f of x minus k, if you have to transpose that k, right, and now it's positive k, what you're saying is for which values of k will f of x is equal to k have one real root, meaning for which values of k will this intersect, okay, with the parabola once. And when they say k, it really comes from, because we can look at them as they're two graphs. F of x is equal to a specific thing, okay? It's a parabola. And then k, that is y is equal to k, meaning y is equal to any real value, a constant value. So it could be y equals 5, y equals 2, okay? But really what this is it's a horizontal line. That's why it's y is equal to. Let's look at the graph. Let's just bring that graph down so we can better understand this. Okay, so it sounds a lot similar to the previous question, because you see in the previous question, they gave us a gradient, right? And they told us that we need to calculate that y-intercept of h that will ensure that, that graph with a gradient of -2, the straight line with a gradient of -2 will be a tangent to the graph, so it intersects with the parabola once. In this case, we're also looking at a line that intersects with the parabola once because it must have one real root. But we know now that this is a horizontal line. Okay, so let's draw a horizontal line. This is our y equals k line. You see that if you move this line, like all through here, it always intersects with the parabola at 2 points. So it has two roots. Okay, so here and here. If you push it down, here and here. And that's not what we want. We want one real root. Now, looking at the parabola, there's one particular place that you can move this line and it will only intersect with the parabola once. And that is over here at the turning point. So that's what we could use. We could just use this point over here, the turning point. So we would need to find, since this is a horizontal line, okay, y equals k, we need to find out what exactly k is at this point. What is this y value that we have here, y-intercept really? Okay, so you can see it's the y value of the parabola's turning point. So let's get the equation of the parabola and then we can use that. So here it is. And we're going to take this, and we know that this is f of x, and let's find that turning point. So we can just use the turning point formula to find it. Don't go ahead and just start completing the square. That takes too long. So we can find the x value of the turning point first by saying x is equal to -b over 2a, and then x is equal to, and then we can find it by, we could have also used nature of roots though, but this method is still fine. So let's go -b, and b is -4, so -4 over 2 multiplied by 1. So x is equal to +4 over 2, which is equal to 2. So we know the x value. So this occurs where x is equal to 2. And then what is that y value? So the y value, and let me not even put attention on that because we're solving for k. We're not really bothered about what that, x value is in the answer. So we'll say f of 2, and let's just find this. So this is 2 all squared minus 4 times 2 minus 5. And then f of 2 is equal to, and that is 4 minus 8, which is -4, minus 5 is -9. So we know what k is here, okay? When k is equal to -9, then this line is going to intersect with the parabola once. So it has one real root, okay? So here we can say we know that this is where k is equal to -9. Now, remember how they put a restriction here? So we also have to consider this. They put a restriction at this point saying that the graph will not go beyond this. They said x is an element of, they gave us our domain. X is an element of -infinity all the way to 6. So at this point 6, the graph is cut off. So I'm going to draw a line here to cut off that graph so it doesn't go anything beyond that, meaning you will not have any graph here as explained in the beginning. Now, because of that, that kind of solves a problem that we were having here when we were trying to see where it intersects with this graph once, okay, at one point. You see, all through here, it intersects twice, here and here, here and here, and just because of the way the parabola looks. But if we cut off the graph at this point, then after this point, you're no longer going to have an intersection on this side. You will only have an intersection on that side. And that's one real root as well, one point of intersection. So that's another thing we can consider. So I'm going to extend this line, this parabola. And if we extend it, you see that, let me just remove that. We don't really need that there. Okay, if you extend it, you see that when you move this graph, anything beyond whatever this is, we need to find out that y value. Then there, it has one point of intersection. Okay, one point of intersection. So there are two answers we have to consider. Let's find out what exactly the y value is at this point. And we can see that this is where the x value is equal to 6, okay, because it's cut off at 6. So what is the y value at 6? And we can do that by taking the graph of f and substituting 6. So we say f of 6 is equal to 6 all squared minus 4 times 6 minus 5. And this gives us, so that's 36 minus 24 minus 5. These together, you can just say 36 minus 5 is 31. So 31 minus 24 is the whole 30 minus 24 is 6. And then plus 1 is 7. Okay, so that is equal to 7. F of 6 is equal to 7. So this actually tells us everything now. So if we know that this is where it has an x value of 6 at 7, then it means that if this graph, this horizontal line, is y equals anything greater than 7, then it's always going to intersect with the parabola once at one point. Okay, there has 1 point of intersection and 1 point because we don't have any graph on that side. So yeah, that's another thing we'd have to consider. So we can tell them that k is equal to -9, right? Or k should be anything greater than 7. And that is where it will have one real root or 1 point of intersection. And that is it for question 6. Question 7 says, the graphs of f of x equals negative, and then we have b to the power of x plus 8, and g of x is equal to 3 over 2x plus 7 are drawn below. A and B, so A is -2 and 4, and B are points of intersection of f and g. B is the y-intercept of both graphs f and g. And the first question is to write down the coordinates of B. Okay, so this is the y-intercept. Now, in this, we could use either one of the equations. It would still work out. You see, at the y-intercept, the x value is 0. You see that we could still find it using f. So we can just do that. Use f of x and rewrite. And now, in place of x, we can just substitute 0. So we're just saying raised to the power of 0. Anything to the power of 0 is 1, okay? So this gives us -1 because of the negative outside the bracket, and then plus 8. So 8 minus 1 is 7. And so the coordinates of B are 0 and 7. And that is our answer. Moving on to the next question. Question 7.2 says, show that B is equal to 1 over 2. Okay, so finding the value of B. We can just use a point on this graph. You can't use this one. It's not going to work. So we can use A. Okay, so let's take the graph of f again. Okay, so that's the equation of f. And we're just going to find B using this point A. So -2 and 4. So -2 and 4. And so in place of x, we substitute -2, and in place of y, we substitute 4. So this is 4 equals negative, and then b raised to the power of -2 plus 8. Okay, so in this case, the coefficient of your base is negative. You might as well just transpose it. So now we have positive in front of it, and then raised to the power of -2 is equal to, and we still have the 8 here, and when we take the 4 over, -4 gives you 4. Okay, so at this point, we can just rewrite this so that it has a positive exponent. Right now, it has a negative exponent, but it's in the numerator. So we'll bring it down to the denominator, and now it is b squared in the denominator, and the numerator is 1, the coefficient that was still there, that invisible one. And this is equal to 4, and then we can cross multiply. So this has a denominator of 1. Cross multiply, and we have 4b squared is equal to 1, and then divide both hand sides by 4, b squared equals 1 over 4, and then finally square root both hand sides. But just remember that this is the base of an exponential function. It cannot be negative. If not, it won't be an exponential function, okay? So b is finally equal to, it will be positive or negative, but we know that b should be a value greater than 0. So b is equal to 1 over 2, and that is our answer. Okay, so there we have shown that b equals 1 over 2. Moving on to the next question. The next question says, write down the average gradient of f between a and b. Okay, so between a and b. We know that b is, actually, I just see that it doesn't matter, but we know that b, the point, the coordinate is 0 and 7. But it's not necessary to find this gradient, because do you see that A and B are points that lie on the graph of G? And we know the equation of G, meaning we know its gradient. So the average gradient between any point on this graph of G would be exactly 3 over 2. So that would be our answer. So we can tell them that the gradient of AB is simply equal to 3 over 2. And that is our answer. Moving on to the next question. Then question 7.4 says, write down the equation of the asymptote of f, so of our exponential function. So there's our exponential function. You can see the asymptote is always that value that was added or subtracted. Okay, we can say added. So it's in the form of, it's an exponential function, so it's in the form of a multiplied by b raised to the power of x minus p plus q. And so plus q, that would be your horizontal asymptote. So we can see that it is 8. And it's a horizontal line, so it starts with y is equal to. So y is equal to 8. And that is our answer. Moving on to the next question. Question 7.5 says, calculate the vertical distance between f and g at x equals -1. Okay, so between f and g. So here is x equals -1. We don't really know where it is, but we know this is -2 over here. So -1 is somewhere here. Okay, so you see that f is actually above g at this point where x equals -1. So we're just finding the vertical distance, meaning when we find this point over here, that y value, okay, whatever that is, and then for that same x value of x equals -1, we're going to have to find the y value of this graph of g, okay? And then we'll take that, and to find that vertical distance, we'll say the y value of f minus the y value of g, and that will give us the distance between that line where x is equal to -1. And that's all we're doing. So let's just find the y values first. So we can see that we were using the graph of f. We'll find the y value of the graph of f at x equals -1. Okay, so that is equal to, we know b is now 1 over 2. So the equation of f is negative and then 1 over 2 raised to the power of x. So we'll say -1 over 2 raised to the power of -1 and then plus 8. Okay, let's find that y value first. So that's going to be 2, -2, 8 minus 2 is 6. So this is 6. And then we need to find the y value of g as well. So the y value of g, when we substitute, it's a straight line. It was 3 over 2x plus 7. Okay, so that is 3 over 2 times -1 plus 7, which is 7 minus 3 over 2. And you can write this as 14 over 2. So that is going to be 11 over 2. Okay, so the y value here is 11 over 2. And all we're saying is, because we can see that the graph of f, the red graph, is above the graph of g at this point, we're just saying the y value of f minus the y value of g, and that will give us the vertical distance. Okay, so vertical distance equals, so we'll take f of -1 minus g of -1. Okay, and that is just 6 minus 11 over 2. We can rewrite 6 as 12 over 2 minus 11 over 2, which is 1 over 2. So our answer is 1/2 units. And that is it for this question. Okay, and that is the vertical distance. 7.6 says, describe the transformation of f to h if h of x is equal to 1 over 2 raised to the power of x minus 5. Okay, let's look at them side by side. F of x was negative and then 1 over 2 raised to the power of x plus 8. And h of x is, as we can see. Okay, we can see it already, so we can just compare. So what happened first? Notice how this is no longer negative. Okay, it's now positive here. So the only way you could have done that is if you took the y values of f, right? So to find h of x, they clearly took the y values of f and they multiplied them by -1. Okay, so we said negative f of x. And so that will cause you to say negative and then substitute the graph of f of x in here. So this is negative and then 1 over 2 raised to the power of x plus 8. And when you distribute, you would get positive 1 over 2 raised to the power of x and then -8. And this is what it would look like once you multiply the graph of f by -1, okay, the equation of f. But then that doesn't really explain everything, because this is what it would look like. So what did we do to get from this to this point? Okay, so do you see that now we've got this side? Great. But now we're at -8 here, and here we're at 5. How did we get from -8 to 5? So that's the asymptote, right? So the graph now lies above the asymptote first, and it's decreasing. But then -8, y is equal to -8 would be your asymptote, but this one has y equals -5. So from -8 to -5, we clearly shifted this graph up by how many units? We moved it up by 3 units, okay? From -8, -7, -6, -5. So that's what happened. They simply applied this, and we'll speak about what this means, and then they shifted the graph up. So h of x clearly went through this transformation. So we went f of x and then plus 3. And so you see that if you do that, you end up with h of x, which is equal to 1 over 2 raised to the power of x minus 5. Okay, so now let's speak about what happened, okay, the transformation. So we said negative f of x. You're applying a negative to the y values. When you do that on a graph, what you're doing is, let's just take a point, 1 and 2. If you make the y values, all the y values of this graph negative, this point will now become still 1, but now the y value is -2. Okay, that's if you multiplied its y value by -1. It becomes -2. So what happened? How did it move from here to here? Well, this was not a shift, okay? It didn't shift up or down or anything like that. So if it's not a shift, and we can clearly see we multiplied by -1, it was a reflection. But a reflection through what axis? It would be through the x-axis, okay? It was here before, and now it's reflected here. So it's a reflection in the x-axis, and then what else happened? This graph was shifted 3 units up as well. So those would be the two things that happen to f so that it can become h. So we can finally tell them that the graph of f was reflected through the x-axis and shifted 3 units up to obtain h. Okay, and that is our answer. Moving on to the next question. Question 7.7 says, for which values of x is f of x greater than or equal to g of x? Okay, so f of x greater than or equal to, let's look at where they are equal, and then we can see where they're greater. And this really, from 2 questions up, this really helps us a lot with this. Okay, so you can see that the graph of f is marked in red and the graph of g is marked in blue. Where is the graph of f of x greater than or equal to g of x? Well, they're equal at a and b, and then all through here, do you see how the graph of f lies above the graph of g? So it has greater y values than the graph of g, and so that's what we're looking for. So it happens all through here within this region, and so we can see that that starts at -2. This is the x value that we have here, and it ends here at this y-intercept b. Okay, so the x value that it ends at is 0. So this works all through where x is greater than or equal to -2, but less than or equal to 0. Okay, and that will be our answer. So you can finally tell them this means that x is greater than or equal to -2, but less than or equal to 0. You can write it like this, or you can also write it like this. So you could say x is an element of, so in interval, so this will be -2 to 0, but we're going to use square brackets because you see that the graph of f and g were equal at x equals -2 and 0. So that's why we had greater than or equal to and less than or equal to. So we'll use square brackets for both. So if you write it like that or like this, it's fine. And that is it for question 7. Question 8.1 says, a Google Chromebook costs 14,500 Rand and depreciates, okay, by 13% per annum compounded annually, calculated on the reducing balance method. Okay, so this is compound depreciation or compound decay. Okay, so we know that it is compound. We're just going to keep that in mind. Calculate what a Google Chromebook will be worth after exactly 5 years. So we're just watching this depreciate. Okay, so we know that we're using the compound decay formula, which looks like this. A equals P times 1 minus I raised to the power of N. And so the amount that we're starting off with, this Chromebook initially costs 14,500. So that is our principal amount. That is 14,500. And then 1 minus our interest is 13% per annum compounded annually. So that is 0.13. And then we know that it depreciates for 5 years. So raised to the power of 5. And we can clearly see we're trying to find the value of A. So let's find our answer and round off to 2 decimal places. So the Chromebook would cost exactly 7,227 Rand and 10 cents. So that is our answer. Moving on to the next question. Question 8.2 says, Khoza deposits 15,000 Rand into a bank account for a period of 10 years. The interest rate for the first 4 years is 6% per annum compounded monthly. For the next 6 years, the interest rate changes to 10% per annum compounded semi-annually. And then they say 8.2.1, convert the nominal interest rates to annual effective interest rates. Answer is correct to 4 decimal places. Okay, so you see in this question, it's funny how they started off telling us all this information about this and then they jumped to nominal and effective interest rate, but that's fine. You see, with nominal and effective interest rates, this is how it works. So the bank quotes a specific amount and says it's compounded monthly, right? So for example, 6%. Just because 6% is compounded monthly and this is the interest rate they've quoted you, it doesn't mean this is the amount that you end up getting if you look at it within a full year. Okay, because interest gains interest on interest. What happens is at the end of the year, that interest rate is much higher. Okay, so you will notice that the effective interest rate, the annual effective one, is always going to be higher than the nominal, the one that the bank quoted. Okay, so that's just a bit of a backstory. And the formula to calculate the nominal or effective interest rate looks like this. It's 1 plus I effective is equal to 1 plus I nominal over n raised to the power of n. So this is the nominal, that's the effective. This is usually to the power of 1, but it's not necessary, okay? It's just because it is compounded annually. So for both interests quoted, that different compoundings, we're going to use this formula. But from this formula, you can already see to find the effective interest rate, and they specifically said they wanted it as a rate. Okay, so we're going to simply take 1 over, and so this is going to be 1 plus I nominal over n to the power of n minus 1. And so this is what we're going to use. Okay, so the first info that we had that the interest rate for the first 4 years was 6%. Okay, so the interest was 6%, but it was compounded monthly. Okay, so this first interest was compounded monthly, and let's just deal with the 6%. Okay, so we will say to get the effective interest rate here, we'll say 1 plus, and this is what we were quoted, 6% per annum compounded monthly. So 6% as a decimal is 0.06. And then it's compounded monthly, so we divide it by 12 so that it gains interest every month. And then raised to the power of 12, minus 1. And we can get that interest. Okay, so this is what we have. And they said round off, but they did say find the rate and then round off to 4 decimal places. So I'm just going to rewrite this as it is first, and then we're going to multiply. So don't write the full thing, just enough. And then we will multiply by 100 so that it is expressed as a rate. So multiply by 100. And so our answer, rounded off to 4 decimal places, would be 6.167. And then this 8 after that 4th decimal point of 7, that's going to help that round up to an 8. So that rounds up to an 8 and we'll say percent, and that is our answer there. And then the next one will be the 10% per annum compounded semi-annually. So let's just put that down. That's the 10%. Okay, so we're going to use the same formula again. I effective equals 1 plus, but in place of our interest, it is 10%. So that's 0.1, or you can say 0.10, it's fine. Okay, now it's compounded semi-annually. So that will be divided by, if you're looking at semi-annually, that's half a year. So half a year, meaning the year is divided into 2 parts. It's going to earn interest twice in a year. So divided by 2, raised to the power of 2 minus 1. And then that's all we're going to just go ahead and change over here. We're going to change that. Okay, and that gives us 0.1025. And if you convert it to a rate, it's just going to move up by 2 decimal points. So if you just multiply that by 100, you can do that, but it's not really necessary. All you're going to get is 10.25, and that is it. Okay, so no other points come after that. So those would be our answers. That's our first answer, and that is our second answer. We'll see why they wanted us to convert it. Okay, moving on to the next question. Question 8.2.2 says, hence use the effective interest rates or otherwise calculate the future value of the savings at the end of the 10-year period. Okay, that was really nice of them. So now you don't have to consider the compoundings and stuff. They're all just going to be compounded annually, okay? So let's look at our timeline because this is clearly a timeline question. So 15,000 is deposited first, and then it's deposited for a full 10 years. We'll keep it like this. Our timeline, we can start at T0, okay? And then what happens here is 15,000 Rand is invested. Then remember how first we had the interest rate for the first 4 years was 6% compounded, monthly, per annum compounded monthly. But we don't have to consider that anymore. Now what we have to take is this, okay? And we're going to use it like that, clearly. So just use it as a decimal. Okay, so we need to take it like that. So for the first 4 years, from T0 to T4, and the reason we look at it like that is because, so this is where the money comes in, and then after a year, this money will gain 1 year's worth of interest, okay? And that's why we start at T0. So from term 0 to term 1, the interest rate was, and we're just going to use this interest that we have here. So that is that 6.1678, okay? 6.1678, we're going to use that. And then for the next 6 years, so till T10, that is, we're going to use this 10.25. 10.25. Okay, so let's go ahead and invest this money. This is going to be compound interest growth because money is going in. It gains interest because of the interest attached to the account at these different time periods. So we're going to use this formula, A equals P times 1 plus I raised to the power of N. Okay, so this is trying to see what the future value will be. It's going to be, we start at 15,000. And then let's look at the first thing that happens. This money gains interest at this rate. So as a decimal, this is now going to be 0.061678. Okay, now it's not going to be, I don't know why I put it up. It's not going to be compounded monthly anymore. It's just going to be like that. So raised to the power of, now for how long did it have this interest rate? It had it for 4 years, so we're going to raise it to the power of 4. Not 4 times 12 anymore because it's not even compounded monthly anymore, okay? We're just looking at that interest per year. It's the effective interest rate, okay? So it's an annual interest. So now the next interest we had was 10.25, right? You're not saying plus because no money is going in again. It's just one deposit of 15,000 and that's it. So you're multiplying, okay? So that it has both interest attached to 15,000. Okay, so 1 plus, and we have 0.1025 raised to the power of, that stayed for the remaining 6 years. So raised to the power of 6. And that is what we have. And let's finally just get our answer. And our final answer is going to have 34,224.26 cents. And that is our answer. And that is it for question 8.2.2. Question 8.2.3, the last question for question 8. We have the interest rate for the first 4 years remains 6% per annum compounded monthly. And then for the next 2 years, okay, we're just going to have to put down our timeline again. Okay, so it's still for, I think, 10 years. Yes, it's still 10 years, but let's see. They say the interest rate for the first 4 years, right? It remains 6% per annum compounded monthly. Okay, so till T4, it's still 0.06, but it seems like they're using this now, okay, over compounded monthly, so divided by 12. And then they tell us that for the next 2 years, the interest rate is now X% per annum compounded quarterly. So for the next 2 years from T4 to T6. So the interest is X% per annum compounded quarterly, so divided by 4. And then they say for the last 4 years, the interest rate is X% per annum compounded semi-annually. So also the same rate, okay, but just compounded semi-annually. Okay, so from T6 to T10, it is X% as well, but compounded semi-annually, so divided by 2. Okay, so we just know these are the interest rates attached to all of these. And what they tell us is if Khoza receives 48,897 Rand, okay, and 3 cents at the end of the 10-year period. So this is what he gets at the end. It's 48,897.03. At the end of this period, the 10-year period, determine the interest rate for the last 6 years, i.e. the value of X. Okay, so just find the value of X. So it's still the same amount going in. It's still 15,000 Rand. And we're just going to have to substitute this and then find the value of X. Okay, so again, using the compound interest growth formula, we would say A is equal to P times 1 plus I raised to the power of N. So the final amount, which we have, okay, as 48,897.03 is equal to the investment, which is 15,000 multiplied by, and now we just need to be careful. Notice that there are 2 different interest rates, but remember there are 3 different compoundings. These ones are exactly the same, but the compounding is different. So you need to have 3 brackets. Just remember that. So it's going to be 1 plus, and the first interest rate is 0.06 over 12. And this lasts for how long? From T0 to T4, which is 4 years. Okay, but remember that this is 4, but you need to multiply it still by 12. The reason is it's compounded monthly now. So you need to ensure that this is in terms of months, okay? And it earns interest every month. And then we'll say multiplied by, and what do we have? We have 1 plus X over 4 raised to the power of, and this was for 2 years, but it was compounded quarterly. So you'll say 2 times 4. So it is 8 quarters in total. And then multiplied by 1 plus, and our interest there is X over 2. And that lasts for 4 years. So that's 4 multiplied by 2. Okay, so semi-annually. And that is what we're solving for. Okay, so let's go ahead and solve for X. We'll find the value of X in all of this. Let's look for a quick way to find X. So since X is here, and these 2 are also still being multiplied, we can simply get rid of everything here. So we're dividing both hand sides of this equation by all of this. Okay, that will all be numbers, not including X. So divide both hand sides of the equation by, and that is going to be 15,000. I'm just going to put that in decimal form or as a fraction. 1.0.06 over 12. Okay, yeah, that's fine. 1.005, and then 4 times 12 is 48. So we're going to say raised to the power of 48. And we're just dividing both hand sides by this number. Okay, so we know that these would cancel, right? They'll be gone. But this, let's just simplify that as well. That is, well, they have the same exponent because 2 times 4 is 8. 4 times 2 is also 8. But their base is not the same though. So this is a situation where you have, like, for example, X times Y, right? But they're both raised to the power of 2. You could have just written them as XY all squared. Okay, so we can't just do that. So this is 1 plus X over 4 multiplied by 1 plus X over 2. And then they're all just raised to the power of 8 is equal to, and let's finally find this answer. Okay, and as a decimal, I actually don't like to leave it as a decimal. I would rather just solve first because I just don't want to keep decimals. So if it's still equal to all of this, we're going to have to now, to get to the x, you see that the next challenge would be this 8. So you need to find the 8th root of both hand sides of the equation. Okay, so if you find the 8th root and the 8th root, I'm only doing this just so that if we make a mistake, we can always just backtrack. So this is now going to be, let's just multiply them. They would give us, it's going to be, yeah, I can see how it's going to be a quadratic equation. So this is going to be 1 times 1 is 1, and then that's going to be an x over 2, and then an x over 4, and then they will give us x squared over 8 is equal to, and then all of that. Okay, at this point, it's safe to just find this answer because we're going to have a quadratic equation here. Okay, so this is 1.125 and then 0, 0, 0. So it really just rounds off to this. Okay, so let's just get this as a fraction. 1.125 as a fraction is 9 over 8. Okay, so let's rewrite. I'll just write this with the x squared first. So we have x squared over 8 and then plus x over 4 plus x over 2. We'll add them using LCD. And so this is 9 over 8 that we have. Okay, so this denominator is 8. And we can make this 8 by simply looking at all their denominators and asking how did we get to 8. So here, this is already 8. So that will stay x squared. Now with the second term, we have x over 4. So how do you get this 4 to become 8? You multiply by 2 in the numerator and the denominator. So that becomes positive 2x in the numerator. And then this, you multiply that numerator and denominator by 4 to get that denominator to be 8. So that's going to be positive 4x. And then for the 1, you just multiply that by 8 is equal to 9 over 8. And here we have equivalent fractions, so we can just get rid of the denominator. You can just decide to multiply both hand sides of this equation by 8, and then it's gone. So therefore, x squared, and we have positive 6x plus 8 is equal to 9. And if you transpose the 9, we have x squared plus 6x, and 9 minus 8 is negative 1. We know this can't factorize, so we're going to have to use the quadratic formula. Okay, so this is equal to, and we'll say x is equal to, and we have negative b, so negative, and then b is 6, plus minus the square root of 6 all squared minus 4 times 1 times negative 1 all over 2a, which is 2 times 1. And let's get our solutions for x. Okay, so 2, 7, or x is equal to, and if you change that to a minus, okay, it's already negative, so you know that the interest can't be negative. So just keep that in mind. So we're not going to accept this answer. We'll accept this one. And the question specifically was, what is the value of x? But we know that this is a rate. So we're going to put it as a rate by multiplying it by 100. And so therefore, x is equal to, that's going to be 16.23%. Okay, so that is our answer. That rate is 16.23%. And that is it for question 8. Question 9.1 says, a certain company uses a camera detector system to detect trespassers. 2 independent cameras, A and B, are installed, one in the front of the main gate and the other one at the back of the building. If someone trespasses, the probability that the person will be detected by camera A is 0.5, and the probability that the person will be detected by camera B is 0.6. Now, the question is, if there is a trespasser, what is the probability that the trespasser will be detected by at least one camera? Okay, so this is the scenario we have. We have this building and we have a front gate and a back gate. So there's a camera in front of both gates. Okay, so we have one camera over there and one at the back. And we know that the probability that if there is a trespasser, that they will be detected by the camera in front, that is 0.5. So it's a 50% chance. So that is 50%. Okay, so there is a 50% chance that they will be detected by this camera in front. And 0.6 for camera B. So there's a 60% chance that they will be detected by the back camera. So maybe they're like coming in from this side, okay? But the main point is that these are two independent cameras, okay? This camera detecting the trespasser does not affect this camera detecting that trespasser, okay? So just because camera in front detected the trespasser, camera A, does not mean that camera B will not detect. Okay, so they're independent events. They can occur at the same time. That's something we need to keep in mind. And so the question is specifically, what is the probability that the trespasser will be detected by at least one camera? What that means is they can be detected by camera A or by camera B, at least one of them. Okay, so keep that in mind, A or B. And this is really where we're going to find this answer. Okay, so don't really need this. This is just an explanation. And so what we're trying to do is find out the probability of A or B occurring. Okay, at least one. It can be either one. So we know that the formula for probability of A or B is the probability of A plus the probability of B minus the probability of A and B. Okay, and remember again, if you look at it in a Venn diagram, this is what's going on. We look at the probability of A, the probability of B, and so if we say the probability of A and the probability of B, so we added the probability of A and then we're saying plus the probability of B, right? You see that we've already taken this entire circle, including the intersection, and then you're adding it to this entire circle, including the intersection again. And this is why we say minus the probability of A and B, so that we don't add that twice. So we remove it, okay? And so that's where that formula comes from. And we're going to add them, but you see that in order to do that, we only have the probability of A occurring and B occurring. We don't have them jointly occurring. So we need to find that. Now we know that these events are independent, okay? They told us that they were independent, two independent cameras. One occurring does not affect the other occurring. So they are not mutually exclusive events. Mutually exclusive, they cannot occur at the same time. One occurring means the other will definitely not occur. That is like flipping a coin and say, what is the probability that we're going to get heads and tails? That's impossible, okay? It's going to land on one face. So that would be an example of mutually exclusive events, okay? These are independent. So in order to find the probability of A and B, we're going to find this by saying the probability of A multiplied by the probability of B, okay? And so the probability of A is 0.5, and we're multiplying by the probability of B, which is 0.6, and then we get, that's going to be 5 times 6 is 30, so that's going to be 0.3, okay? So this is what we're going to get. And so we can finally find the probability of A or B, because that's what we're trying to find, the probability of at least one occurring. So that is the probability of A, which is 0.5 plus 0.6 minus 0.3. So that's going to be 0.11 minus 0.3, which is 0.8. And that is our answer. Moving on to the next question. Question 9.1.2 says, determine the probability that the trespasser will not be detected. So if we knew the probability of A or B occurring was 0.8, okay, again, looking at this in a Venn diagram, we know that this is A, this is B. The probability of A or B is the addition of A and B, removing that double intersection that will happen. Okay, so if we're trying to find the probability that the trespasser will not be detected at all, so A doesn't occur and B doesn't occur either, it means we're just trying to find out what is outside of this box. Okay, what is neither in A or B. And how we find out that value there, the probability that none of the events occur, we find that by taking the entire sample space, okay? And we know that the probability of everything occurring, that's just going to be 100%, okay? That's everything in the Venn diagram. And you're going to take that, but we can express it as 1 as a decimal. We're going to say the probability that this trespasser will not be detected We'll find this by saying 1 minus the probability of at least one being detected, because you see how this includes everything here. And so we're just trying to find out what is outside. So that's 0.8. And so that gives us 0.2. And that is our answer. Moving on to the next question. Question 9.2 says, at a certain high school, a survey was carried out on 110 learners. So that's the total learners in this Venn diagram. And they tell us about their subject choices. Okay, so this is about their subject choices. The Venn diagram shows the results of the survey in terms of mathematics, physical sciences, and accounting. Okay, and 9.2.1 says, show that x is equal to 8. Okay, so this one is a very simple one. They give you everything else but x. Okay, so how would you find x? Well, you could take the total that everything would add up to, including the x, okay? And that would be the total. We know that there are how many people, how many students in this survey? There are a total of 110 learners. So when we add up all the numbers, including x, it should give us 110. And so to find out the missing x, take 110 minus everything here. And then that will give you x. And that will complete the Venn diagram. So that's what we're going to do. We'll say x is equal to 110 minus, and we're going to add everything up. Okay, so we're going to do that, and we'll simply say x is equal to 110 minus, and when we add everything up, it becomes 102. So x is finally equal to 8, and that is our answer. Moving on to the next question. Question 9.2.2 says, calculate the probability that a learner chosen at random does only one of the 3 subjects. Okay, only one of the 3 subjects. Let's look at the Venn diagram and just consider. Just remember that x is equal to 8. So let's look at all the learners that do only one of the 3 subjects. When you look at 26, do you see how it's not included in any of the intersections? It's only in mathematics. This means that these learners, these 26 learners, only do mathematics. Okay, likewise, the 24 learners only do physics, and then the 15 learners do accounting only. When you start looking at the intersections, 9 is the intersection of mathematics and physics, but not, accounting. So this means that these 9 learners jointly do mathematics and physics. Okay, they do mathematics and physics. So they do 2 subjects. We're looking for learners who do only one subject. So that will be 26 plus 24 plus 15. But remember, it needs to be the probability. So you need to put it over the total. So we're going to go ahead and say that the probability that they do only one subject, not at least one, only one, that would be 26 plus 24 plus 15, which is 65, okay? And you're going to take that and you put it over that total, 110. So this is 65 over 110. And then you can just get that as a simplified answer. So that is, I'll get it as a simplified fraction. That's fine to just leave it like that because I don't want to cut off anything. So 13 over 22 is our answer. And that is it for this question. Moving on to the next question. Question 9.2.3 says, calculate the probability that a learner chosen at random does mathematics and accounting, but not physical sciences. Okay, so let's look at our Venn diagram. They do mathematics and accounting, okay, and meaning the intersection of them, but not physical science. So excluding physics would only be 12. Okay, so that is our answer. It is going to be, it's simply just 12 out of 110. And let me just get that. So 12 over 110 is simply 6 over 55. And I'm going to leave it like that and not, make it a decimal. And that is it for question 9. Question 10 says, Benny has 2 fair spinners. Circles are divided into 3 and 8 parts respectively. Okay, so we have these 2 spinners. Benny is going to spin both spinners What is the probability that it lands on the same color after spinning each spinner once? Okay, so it spins both at the same time. So we're looking at the probability that they land on the same color. So let me just go ahead and color them in their respective colors first. Okay, so we're looking at the probability that they're going to land on the same color, meaning they can land on red and red or blue and blue. And you see, they can't land on green and green because the first spinner is the only one with green. Okay, so here's how we can do this. We can just see that they're spinning at the same time. Okay, these outcomes do not affect this one occurring. So these are independent events that we have. And to find out the probability that they land on the same color, we're specifically looking for the probability of red and red. We can also look for the probability of blue and blue. Okay, so if I'm saying we're looking for probability of red and red, or it could be blue and blue, notice the use of the word or. It means we're going to add those outcomes. So the probability of blue and blue. And so we're just going to look at them in both spinners. So in the first spinner, what is the probability of landing on red? It is exactly 1/3. Now we need to look for the probability of landing on red in the second spinner, okay, and red. So we would multiply because these are independent events. And so the probability of red in the second spinner, they're exactly 3. So 3 over the total 8 parts that we have, 8 colors. And then we will say plus the probability of blue and blue. So the probability of blue in the first spinner, that's exactly 1/3. And then multiply by the probability of the blue in the second. If we have 3 reds, then there are, of course, 5 blues. So 5 out of 8. And then we just have to find this. Okay, so let's get them individually first. Red and red is, so if we multiply, you see 3 and 3 is going to cancel. You're just going to be left with 1/8. Plus, and then here, well, nothing cancels, but 5 is going to be your numerator, and then 3 times 8 is 24. So that's 5/24. And now we can just add them together. You can just use the calculator, it's fine. But I would just express this as, because they can both be expressed as 24. This can be 3/24 if you multiply numerator and denominator by 3, and then plus 5/24, which is simply just equal to 8/24. But we know that we can divide here, okay, by 8. We have a common factor. So this gives us 1/3, and that is our answer. Okay, and that is it for question 10. Okay, so that is the last question for this paper. I hope you guys enjoyed it. You can leave questions that you have about this in the comment section, and I hope to see you guys in the next video. Bye.